Hello guys, welcome to today class. In this class, we are going to discuss the last topic of Fourier series is nothing but harmonic analysis. The harmonic analysis is nothing but its application of Fourier series. Anybody who come and ask whether you studied any application regarding to the or corresponding to the Fourier series means we studied only one concept is nothing but harmonic analysis. Harmonic analysis is nothing but is an application of Fourier series. This harmonic analysis is very much useful whenever in the practical oriented problem or once you written a program execute based on that if you want to construct a Fourier series there we are going to use harmonic analysis. Now I'm going to say overall this harmonic analysis is one of the method to construct the Fourier series for the core subject. See, core subject means in your optional subject they may be instead of giving a function in the interval you already know that if you want to construct the Fourier series what you want required a function and also required a interval say a comma a plus 2 like that. Okay, whenever function is defined in the interval, then I have to construct the Fourier series. Instead of giving the function in the corresponding interval, they given some set of values. They given some input. They have output. The first row values are input is independent. Y is dependent on X. Once you conducted any experiment or you written a program, you get two sets of values. One is the input, another one is output. Based on that, if you want to find out the approximate Fourier series for the given set of data, suppose data in the form of discrete, maybe the data is in the form of graphical representation. They have a graphical representation. From the graphical representation, you know how to take the x value and corresponding y values on x or y plane. Once you convert the graph in the form of table or discrete data, then how to find out our corresponding Fourier series for the discrete data. Therefore, overall, we have to say that harmonic analysis is one of the method to construct the Fourier series. Suppose data in the form of discrete. Where we are expecting discrete data is in your core subject. That's why we treated harmonic analysis as an application of Fourier series. Now, whenever the data is not a function in the, for example, f of x is equal to e power of x defined over the interval a comma a plus 2l, in such cases, you know how to construct the Fourier series. But instead of giving a continuous function, they given discrete because if e power of x defined in the entire range. Instead of that, if for each value of x, they given the corresponding y value. In such cases, that such type of data we consider as a discrete. For each and every value of x, we have a y value means out f of y or f of x that is output. In such type of values are nothing but discrete. Whenever data is in the form of discrete, how to find out the corresponding Fourier series? There we are using harmonic analysis. We have to find out approximate. That not give us your accurate Fourier series. They are going to give approximate Fourier series. The advantage is this for whenever the data in the form of discrete, how to find out approximate Fourier series? There we are going to use harmonic analysis. Disadvantages here you can't find out the value of A naught, An and Bn. Now I have to find out A naught, A1, A2, similarly B1, B2, B3. See, you can't find out entire A naught, An value or Bn what we already constructed of range Fourier series and also Fourier series. Now here I have to find out each and every Fourier coefficient separately or independently A0, A1, A2, A3, etc. Therefore, this is a disadvantage in harmonic analysis. Okay, this is advantage and disadvantage. Overall, whenever the data in the form of discrete, there if you want to construct approximate Fourier series, there we are going to use harmonic analysis. Now, if you want to construct the Fourier series based on harmonic analysis, how to proceed? Now, for example, f of x is a Fourier series expansion over the interval a comma a plus 2l. But keep in mind, if you want to construct Fourier series based on harmonic analysis means the data in the form of discrete. Whenever data in the form of discrete, we can't find out a naught and an and bn. For example, what is our general expansion of Fourier series for the interval a comma a plus 2l is f of x is equal to a naught by 2 plus summation n ranging from 1 to infinity an cos of n pi x by L, and then summation in ranging from 1 to infinity bn sin of n pi x by L, where what are the formulas for A? Fourier quotient formula A naught is 1 by L, A to A plus 2L. Yeah, these things you already know that f of x with respect to x. And also, what is my AN formula? AN formula is nothing but 1 by L, A to A plus 2L, f of x into cos of n pi x by L with respect to x. And also, Bn is nothing but 1 by L, A to A plus 2L, f of x into sine of n pi x by L with respect to x. Now, this is a general formula for construction of Fourier series in the interval a comma a plus 2L. If we want to go for this formula, what's required here? Required a function must be defined in the range, say a comma a plus 2L. But instead of range, they given discrete data for each value of x having a corresponding y. There we want to construct the Fourier series. Now it's not possible. Why? Because we can't find out A naught, we can't find out A naught, we can't find out An or Bn based on for each values of x corresponding the values of I. If you want to find out, first you have to convert A naught, An and Bn in the form of summation. In the form of what? Summation. Then only is possible I go for discrete data. Whenever the data in the form of discrete, I have to convert integration in the form of summation. Then it's possible I find out A naught, A and B, etc. I think it's clear. Now here, this whenever data I told just few minutes before, whenever data is in the form of discrete or graphical representation, there we are going to use harmonic analysis. Harmonical analysis is one of the method to construct the Fourier series. Suppose the given data in the form of discrete. Now, where we are failed to proceed, we can't find out as usual from the construction of Fourier series, A naught value, An value, Bn value. If you want to go for integration, means function must be continuous. But here is discrete value. How to find out? In that case, first I have to convert this A naught formula, An formula, Bn formula in terms of what actually summation. How to convert in terms of the summation? There we are using one of the property, this definite integral property you already studied where in second QC level. The property is if mean double square bracket is nothing but mean of phi of x. Phi of x is a function just like f of x. Double bracket denotes mean. Mean means what? Mean or average. Sum of all the values divided by number of values. If mean of phi of x is the mean or average, mean or average value of function phi of x over the interval a comma b, then the formula is mean of phi of x can be written as 1 by difference between upper limit to the lower limit of integration of a to b phi of x dx. This is a relation between. Why I have to convert in the form of mean? Mean is nothing but what? Sum of all the values divided by number of values. Their sum means what? Summation. Okay. This is one of the property. What's the property? Mean of phi of x. Suppose phi of x defined over the interval a comma b can also be written as 1 by b minus a integration of a to b phi of x dx. This can also be written as from this formula integration of a to b. Okay. See, please try to understand 1 by b minus a into phi of x. Either write first left hand side or right hand side, does not matter. It's nothing but mean of phi of x. Okay. Using this formula, this property, we try to convert a naught, an and bn in terms of the average. Means there we have to find out sum of the given set of data from the table. Okay. Now, what is my, from using this, first I have to convert, what is my A naught? See, now first I have to find out A naught. What is the formula for A naught here? 1 by n, 0, A to A plus 2n, f of x dx. But we already know that f of x is defined over what's the interval? a comma a plus 2l, a comma a plus 2l. From the property of mean, what's the mean of f of x is nothing but mean of f of x is nothing but 1 by b, a plus 2l minus a, what we get 2l, a to a plus 2l f of x dx. I think you clear from this property. F of x is defined over the interval a comma a plus 2l. The mean of f of x can be written as 1 by 2l into a to a plus 2l f of x dx. Therefore, here I want to multiply and divide it by 2. Once you multiply 2, what we get a to a plus 2l. This is a actually 2l f of x dx. Now, from this property, 1 by 2l, for this 1 by 2l, a to a plus f of x is nothing but mean of f of x. Yeah, f of x is nothing but output. What value have in the second row in the table, that is nothing but our f of x. Dependent on first row. First row variable is independent. Second row variable in the given table is dependent on first row value. Therefore, that implies what is my A naught formula in terms of the average twice of mean of f of x or average of f of x. You know how to find out the mean. Sum of the values divided by number of values. It's possible to find out the sum from the given data because the given data they provide in the form of table. Okay. Similarly, we are going to express our AN and BN in terms of the mean. Now, what is my AN formula? AN formula is nothing but 1 by L a to a plus 2L f of x into cos of n pi x by L with respect to x. Now you already know that this is a one of important thing we have to know that. See, integration of a to a plus 2L f of x into cos of n pi x by L with respect to x means when is possible to find out the evaluation of this function. For example, integration of 0 to 1 f of x dx means when is possible to find out this integral value. Suppose this function is defined in the interval. What's the interval? 0 to 1. Then only is possible to evaluate this function, apply the upper and lower limit. Like that, integration of a to a plus 2l f of x into cos of n pi x by l with respect to x means this product of this function must be defined in which interval? A to a plus 2n. From this property, yeah, from this property, what we get actually multiply divided by 2. From this property, please try to understand the meaning of integration of a to a plus 2l of this product of this function with respect to x means this product of these two functions must be defined in the interval a comma a plus 2n. From this property, what written? From this property, what we get to multiply divided by 2. 1 by 2n into a to a plus 2l f of x into cos of n pi x by l with respect to x is nothing but mean of f of x into cos of n pi x by l. Okay. This is a formula for an. How this is a way to convert integral in terms of the summation. Similarly, what is my Bn? Bn formula is nothing but 1 by L a to a plus 2L f of x sin of n pi x by L with respect to x. Again, the meaning of this integral means product of these two functions must be defined in the interval a comma a plus 2l. From this property, this can also be written as twice of mean of because the 2 is absent. Difference is what we are expecting b minus is 2l. f of x into, what actually sin of n pi x by l. You know how to find out the mean. This is a way to convert a naught, n and bn in terms of the summation. Yeah, this is a now instead of using integration, we are going to use these are the alternative formula to find out the values of a naught, n and bn. But the disadvantage for this formula here, we can't find out generally an. This formula very far n is equal to 1. What's the formula? F of x into cos pi x by l. N is equal to 2. What's the formula? F of x into cos of 2 pi x by l. For n is equal to 1, average is not same as n is equal to 2 and also is not same as n is equal to 3. Now, therefore, we can't find out generally an. If you want to find out this value, first you have to give what's the value of n. Based on the n, we get the corresponding means we have to find out a1 separately, a2 separately, a3 separately, a4 separately. We can't find out generally an because based on n value, this average values vary. This is a disadvantage means we can't find out n generally. We have to find out each and every quotient separately, a1 separately, a2 separately, a3 separately. Similarly, same thing is happen for bn value also. This is a disadvantage. You can't write generally expansion for Fourier series expansion more than equal a comma a plus 2n. Only the possibility here and to expand the series based on each and every Fourier quotients a naught, a1, a2, a3, etc., b1, b2, b3, etc. Therefore, whenever having a discrete data or graphical representation in your core subject, they're going to ask the Fourier series not for entire the summation for n ranging from 1 to infinity. They're going to ask up to first harmonic, up to second harmonic, up to third harmonic. See, if you see, this is a Fourier series expansion. What you know that over the interval a comma a plus 2l. What's the Fourier series expansion for a comma a plus 2l is a naught by 2 plus summation n ranging from 1 to infinity a n cos of n pi x by n and n ranging plus n ranging from 1 to infinity b n sine of n pi x by n. No, just 1 minute before I told, whenever they have a discrete data, you can't find out n or bn. I think it's clear. Once you give the different value of n, 1 to infinity, then you change the mean value. You can't say for this is the entire mean value for n is 1, 2, 3, etc. For each a1 we get different value, a2 is different, like that b1, b2, b3 also. Now, therefore, whenever they're having a discrete data, they're going to ask to construct the Fourier series up to first harmonic. Up to first harmonic means the constant term is fixed. A naught by 2, why you treat that as a constant? Because it's not involving any cosine function or sine function. What's the first term of the summation? A1 into cos of pi x by L. And also first term of the second summation. What is that? B1 into sine of pi x by L. This is nothing but Fourier series up to first harmonic. Up to first harmonic. Okay. Similarly, suppose they're going to ask up to second harmonic. Means keep in mind A naught by 2 is a direct current they are asking or constant term. A naught by 2 is first two terms of the both the series. A1 into cos of pi x by L and second values a is n is equal to 2 a2 into cos of 2 pi x by L and also first two terms of the sine series b1 into sine of pi x by L and also b2 into sine of 2 pi x by L. This is nothing but up to which harmonic? Fourier series up to second harmonic. Yeah. Similar way, we are going to construct up to first harmonic, second harmonic, third harmonic. Means you can't construct generally what is the Fourier series for the discrete data. This is a disadvantage for harmonic analysis. Advantage means whenever having a discrete data or graphical representation, how to find out approximate our Fourier series expansion. There we are going to use harmonic analysis. But disadvantage is you can't find out generally what is my A naught, En and Bn. We can't construct general Fourier series. Its possibilities only is to construct Fourier series up to first harmonic, up to second harmonic, up to third harmonic. This is a disadvantage based on harmonic analysis to construct the Fourier series. Why you treated this is application of Fourier series? Because we are going to construct the Fourier series based on your application oriented problem, means related to your core subject. That's why this is nothing but one of the application of Fourier series. But keep in mind it's possible to construct the Fourier series, but you can't construct general Fourier series from the harmonic analysis. This is a way to construct the Fourier series for up to first harmonic, up to second harmonic, up to third harmonic of the given discrete data or graphical representation. I think it's clear how we have to find out A naught, An and Bn. How I convert in the form of summation. Is a mean, double bracket is mean. This is one of the definite integral property you already studied where in PO level. Okay. Now I move to the problem. Yeah, same formula for half range Fourier sine and cosine series. See, for example, before moving to the formula, I'm going to explain for half range sine and cosine series. Now I'm going to take what actually harmonic analysis for half range cosine and sine series. Okay, what is the alternative formula in harmonic analysis? HCA means harmonic analysis. For my convenience, I use that abbreviation. That's all. Now here, what is Fourier half range cosine series? You know that cosine series for f of x over the interval 0, L. What is the formula is f of x is equal to a naught by 2 plus summation in ranging from 1 to infinity a n a n cos of n by x by L. What is my formula for a naught is 2 by L 0 to L f of x dx. What's the formula for a n is 2 by L 0 to L f of x cos of n by x by L with respect to x. I think you are clear how we get these steps. Okay. In the next step, see here we have a discrete data. I have x corresponding f of x. For each value of x, we have y value. Means y is f of x like that, discrete data. This formula doesn't work because function is not continuous over the interval 0, n. We don't have any function overall in the range or in the limit. Now, for each and every value of x, we have f of x. Therefore, I have to convert this a naught n in terms of the summation with help of that same property. Now, here, observe carefully here, f of x is defined over the interval 0, L. Therefore, mean of f of x is nothing but 1 by b minus a. What is b minus a? Is 1 by n. 0 to L f of x dx. Okay. Therefore, from this formula, now what is my a naught? A naught is nothing but what actually 2 times of 1 by L 0 to L f of x is what actually mean of f of x or average of f of x. Similarly, for a n, yeah, this entire the function, this function must be continuous over the interval 0 to L, 2 is separate, 1 by L 0 to L f of x cos of n pi x by L with respect to x. Because our range is 0 to L in half range. What we get the formula? Mean of f of x into cos of n pi x by L. Keep in mind either maybe half range or for half range sine or cosine series or for construction of general construction of Fourier series. Finding a0, a1, a3, etc. a1, a2, a3 must be same formula. Now this is for n is equal to 1, 2, 3. Similarly, for half range sine series for f of x over what's the interval 0, L is what's the formula? F of x is equal to summation in ranging from 1 to infinity what actually bn sine of n by x by L where what is my bn formula? 2 by L 0 to L f of x sine of n by x by L with respect to x. But in the next step, now we already know that f of the meaning of this integral means the product of these two functions is defined over the interval 0 to L. From this property, what we get 2 is as itself mean of the product of these two functions f of x into sine of n by x by L. Yeah, this is a formula for Bn. Suppose the function is an half range sine series. But overall, I'm going to give a conclusion. Either maybe half range or maybe a general construction of Fourier series. In all the case, a0, an and bn formula must be same. But keep in mind, in the general case, our overall interval is a comma a plus 2. A general construction of Fourier series for Based on the general question of Fourier series, if you want to construct the harmonic analysis for a Fourier series, so general construction is interval is a comma a plus 2 n. When you're talking about sine series or cosine series, there the interval is 0 to n. So the formula is same, but taking the value of L is different. For general Fourier series is a comma a plus 2 n. For half range sine or cosine series is nothing but 0 to n. Based on that, carefully I have to choose the value of n. Because again, once you convert in the form of what about summation also, the value of L, the role of L is very, very important. You must and should have to care for that. That's a very, very one of the important thing. Now, before moving to the next step, I'm going to brush up for 1 minute for how we had to get what's a harmonic analysis. Harmonic analysis is one of the method to construct the approximate Fourier series for the given data in the form of discrete or maybe in the form of graphical representation. Whenever data in the form of table or discrete data, there is not possible to find out A naught, A and B and using this integration. And to convert that for integration in terms of the summation, then easy to find out what is my Fourier series for the data in the form of discrete. Therefore, now what we did, now we are going to consider one of the property. If suppose phi of x is defined over the interval a comma b, the mean of phi of x is nothing but integration of 1 by upper limit minus the lower limit of integration of lower to upper limit phi of x dx. With help of this formula, we have to convert a naught alternative formula for a naught, n and bn. But you can't find out generally an and bn because this average is not same for 1 to infinity. Based on n, is change the value of average for a1 to a2, a2 to a3. Therefore, this is one of the disadvantage to find out an and bn. Therefore, whenever they're having a discrete data, they are not going to ask to construct the what actually Fourier series. They're going to ask construct Fourier series up to first harmonic, up to second harmonic. Up to first harmonic means I have to take a naught by 2 is a constant term, is a free from both cosine and sine function. I have to take first value of n of the summation for n and bn. Sum of these terms is given as first harmonic. Similar second harmonic means a naught by 2 first two terms of the summations of n and bn that give rise up to the second harmonic. Now similarly, suppose if you want to check in the half range half range sine and cosine series, the formulas must be same for finding a naught or an or bn, but taking the value of n is 0 to n. There in the general construction of Fourier series is a comma a plus 2n. This is one of the important thing we have to remember that. The next move to one simple problem for in today's class. Okay. I'm going to write one of the simple formula. If you want, I'll zoom out for this. Those who want interacting in one screenshot, observe carefully. Yeah. This is my one interesting what I explain in one screenshot. Okay. Now I move to the one simple problem. Yeah, the problem is I'm going to write the problem. First the problem. First problem is obtain the constant term and the coefficients of the first cosine and sine terms in the Fourier expansion using the following table. The following table. Okay. Yeah, the table is nothing but they given x and y. Keep in mind whenever they provide a discrete data, first row variable is independent, it's input. Second row variable is output. Y is dependent on x. Instead of f of x, what they given, y is nothing but here f of x. That's all. Okay. Now 0, 9 and 1, 18 and next 2, 24. Next is 3, 28, 4, 26 and next to 5. 5 is nothing but, yeah, what I told, this is 26, but I written here only 6. Yes, is 26. This is 20. This is the data they provide. I want to find out constant term. You see, you know what is my Fourier series expansion. The Fourier series expansion is f of x is equal to, I'm writing general Fourier series over the interval a comma a plus 2a. It's nothing but f of x is equal to a naught by 2 plus summation in ranging from 1 to infinity a n cos of n by x by l, and then summation in ranging from 1 to infinity bn sin of n by x by l. The constant term means I have to find out which value a naught value. Constant term value means a naught value I have to find out. And also, and the quotient of first cosine. First quotient means n is equal to 1 a1. And first sine term means b1 value. I have to find out here a naught, a1 and b1 value. They are not asking to construct up to first harmony. They want to find out only for constant term means a naught by 2. I have to find out a1 and b1 quotient of first cosine and sine terms of the series. Okay. Now here, before moving to the next step, you know what's the formula, how to find out the values of a naught, a1, a2, a naught, a1 and b1. Before moving to the next step, you please try to understand one of thing, whether table is complete or incomplete. You know the function must be a periodic function, then only is possible to consider the Fourier series. How can you know that whether the function is periodic or not? Now, first value of first row equal to what we have second row must be same as the last value of x corresponding second row value. Keep in mind, first and last value of first row value, the corresponding second row value must be same. Then only say the table is complete. Then only say that the given function is a periodic function. Then only is possible to consider the Fourier series. Keep in mind, what's the first value of x is 0, what is corresponding second row value is 9. What's the last value of x is 5. What is the y value is 20. 9 is not same. 9 is not same. Therefore, table is not complete. Then it's not a periodic function. Keep in mind, this is a way to do that. Before moving to the next step, observe the first and last pair of the first row. Corresponding second row value must be same. Then only say the table is complete. Table is complete is table. The given function is a periodic function. Keep in mind, otherwise you can't consider the Fourier series. There are move to the actually Fourier transform. Now this shows that first value of x 0 is 9, but here last value of x 20, table is not complete. Here I'm adding extra. That's why I'm using what's a different color of 10. Don't feel thing. The problem they given only this much. I want to complete the table. That's why I use extra whatever that different 10. Now, usually first row value must be uniformity 0 to 1, 1 to 2, 3 to 4, 4 to 5. What's the next value? Confidently say that 6. Corresponding 6, how what's an y value? First value of y. Now we say that our table is complete. Once the table is complete, then I have to choose what is my overall interval. What is my overall interval? After once you complete the table, then only I am going to choose overall interval. What is overall interval is 0 to 6. Before I move to the next step, please try to understand first and last value of x must be same as must be is same as the y value, corresponding y value. Then only say the table is complete. Once you choose 0 to 6, this is the interval they given. You 0 to 6 is nothing but what? Start from 0. If I refer to the which case of the general construction of Fourier series 0 to 2l. Yeah, this is a way. Otherwise, you compare with a comma a plus 2l. Immediately we get what is my value. A is 0, a plus 2l, a is 0, 2l is equal to 6. 2l is equal to 6. What is my l? L is equal to 3. L is equal to 3. That implies what is my n pi x by l? What is my n pi x by l is n pi x by 3. This is a way I have to choose the value of L. Please try to understand that after once you get the value of L, not necessary to take the repeated values. Y is repeated how many times? 2 times. Either you neglect first value or last value. But calculation of 0 is easy compared to the last value. Therefore, after once you choose the value of the limit and corresponding L value, we are going to neglect that. Before going to take the value of L, first you observe whether table is complete or incomplete. Complete or incomplete means first and last value of X corresponding second row. First row, first and the last value of first row value have the same value in the corresponding second row. Then only say that the table is complete. Then I have to choose. After that, you are not consider the repeated value more than once. Therefore, neglecting either this or this, and we are going to neglect last value because 0 is easy to do the calculation. What is my next step? The next step is after you neglect that, I have to write what is my the value of see here they given very clearly. I think is the n value. See 0 to 6. Therefore, divided into how many parts? N is 6 values. N is equal to 6. 1, 2, 3, 4, 5, 6. Okay, n is equal to 6. Okay, you know that. Now n is equal to 6. Please try to understand. 1, 2, 3, 4, 5, 6. Therefore, that implies n is equal to 6. Don't take for this original value. After you neglect that, you choose the value of n. What's the n value is 6. Okay. The next, and now we are going to write what is my a naught. What is my a naught formula? A naught formula is twice of mean of or average of f of x. What is f of x is y. It's nothing but sum of the values for I ranging from how many values you have? 1 to 6. Therefore, n is equal to 6. yi divided by total values. What is total value? 6. This is a value for finding a naught. Keep in mind f of x varies. This function is depending upon which value, which variable they given second row. Based on that, we are going to write. What is my a1? Yeah, a1 is nothing but twice of mean of y into what? Cos of n pi x by 3. But what is n? N is equal to 1. Therefore, what we get? Cos of pi x by 3. What's a formula? What's a formula for mean for I ranging from 1 to 6? yi cos of, you have x and y value, actually make it I cos of pi xi by 3 divided by total number of values is 6. Similarly, we are going to write the formula for B1. What's the formula for B1 is twice of, please try to understand, most of the students they doing mistake y. Here instead of cos, what we are going to take sin. Cos of n pi x by 3, we already simplified n pi x by 3, but what is the n value? 1. Sin of pi x by 3 is nothing but from the definition of average, the sum of all the values divided by number of values. Sin of n pi xi divided by 3, whole divided by what actually? 6, whole divided by 6. These are the formula to find out. If you want to find out these values, first you find out sum of yi, sum of this value and sum of this. Now, if you want to find out this sum, must and should have to construct the table. Most of the students, they are not construct the table. They are writing a value directly. You can't write. Madam, I'm using calculator if I get. Then this we are writing a what about that? Table answer conceptually means you must and should have to write each and every step. Construction of table also they have a marks. How many rows? This is for actually x 1, 2, 3, 4, 5, and then 6. And also I have to take another one row is nothing but what actually uh, total. Yes. Now y. X and y are nothing but the given values. What are the given values? 0, 9, 1, 18. And then if you want to use some different color, then easy to identify properly. And then 3, this is 3, 28. And next 4, yeah, I did mistake here. One, just a minute. This is actually 2, right? 224. Yeah, yeah. This is a disadvantage for DC code. We observe this is advantage and disadvantage. Everywhere, in every concept, you have that. Yeah. What is the next value? 2, 3, 2, 3, 4, 5. Not necessary to take 2, 24, 3, 26, and then 328, sorry. 328, okay. 26, last value is 20. Okay. What value they given? Same thing. Next, I want to find out what are the sum I want. This sum I want this. If I'll take y into cos of pi x by 3, and also what's y into sine of pi x by, okay, 5. Yeah. The next is now I'm going to find out. See, observe some of these value know that how to. This is last row. I'm going to take total. What's a total of this? Now, you know sum of these values is nothing but total. Once you take that sum, we get total. What is sum of this value? We get 125 if we want to calculate. Okay. Okay. 125 is the sum. 9, 18, 24, 28, 26 and 20. 125 is the sum of this. You calculate it using calculator. Next, first value, x is equal to 0. X is 0, what is cos 0? 1. 1 into corresponding y value. What is corresponding y value? 9. We get 9. Next, x is equal to 1. Means cos of, what about pi by 3? What is cos of pi by 3? Cos of pi by 3 is 1 into the corresponding, is half. Cos of pi by 3 is half. You already know that. That value must and should have to know. Cos of pi by 3 is nothing but half. Half into 18, corresponding 18 is nothing but 9. Next, move to x is equal to 2 cos of 2 pi by 3 into the corresponding 24. The cos of this, you calculate cos of 2 pi by 3 into y, corresponding y. What is corresponding y is 24, we get minus 12. Again, we get half. Minus half, we get cos of 2 pi by 3 is nothing but minus half into 24, we get minus 12. Next, cos of x is equal to 4. Cos of 4 pi by 3. Cos of, 3, not 4, 3. X is equal to 2 over cos of 2 pi by 3 is minus half multiplied by 24, we get. X is equal to 3 cos pi. X is equal to 3, 3 cos pi. Cos pi is minus 1, we get minus 28. Next, 4. Cos of 4 pi by 3. Cos of 4 pi by 3 is nothing but again we get minus half. Minus half into 26 is nothing but minus 30. Similarly, cos of what about that 5, 5 cos of 5 pi by 3 into y. Y is 20. Cos of 5 pi by 3 is half. Half into 20 is 10. Take this sum, we get 25. Take this sum, we get what actually? 20, minus 25. Please do it. take this 28 plus 28 cancel out. See minus 28, 10, 18. Add positive 28 minus 28 is cancel. What's the remaining? Minus 25. Next, move to the sign. Put x is equal to 0. What is sine 0 is 0. Therefore, 0 into corresponding y, 9. 0 into 9 is 0 only. Next, x is whatever that x is equal to 1 sine of pi by 3. What is sine of pi by 3 is root 3 by 2. Sine of pi by 3 is nothing but root 3 by 2. Into 18, what we get? 9 into root 3. I written root 3 itself after the end because we get a infinite number of decimal. And then put 2 sine of 2 pi by 3. Sine of 2 pi by 3 is actually, now observe, sine of 2 pi by 3 is we get off. Root 3 by 2 again, sorry. Sine of 2 pi by 3. What we get actually? Root 3 by 2 into 24. What we get? 12 root 3. 12 root 3. And next, put x is 3, sin pi. What is sin pi? Is 0. 0 into the corresponding y value also 0. Next, 4. In the 4, again we observe sine of 4 pi by 3 is minus root 3 by 2 into 26. What we get? Minus 13 into root 3. Next, x is equal to 5 sine of 5 into pi by 3 is minus root 3 by 2 into 20. What we get? Minus 10 root 3. You simplify that. Observe everyone they have the minus 23. This is see this is 9 plus 12. What we get? 11. 11 what about that root 3, and then the 23 minus 23 root 3. What we get? Minus 2 root 3 is the total. Yeah. Once we get total, then you have to find out A naught, B1. What is my A naught formula? A naught formula is nothing but what is 2 into sum of these value 125 divided by number of values is 6. It's nothing but what we get after the simplification 41.666. Please round up to 4 decimal value. You do the calculation. Now this approximately we get this is a round up to the 4 decimal. This implies A naught by 2 is nothing but half of this 20.8333. Okay, fine. Next I have to calculate A1. 2 into sum of these values you already know that we already done divided by 6. Simplify that, what we get is minus round up to 4 decimal value t.33. Like that you find out B1 is nothing but 2 into minus 2 root 3 divided by 6. Now you simplify that. After do the calculation, round up to 4 decimal value. What we get here approximately what actually minus 1.1547. Round up to how many? Fourth decimal. Round up to fourth decimal means observe the fifth decimal value. Suppose that value is greater than or equal to 5. You shifted 1 unit to the fourth decimal place. That is called round up method. Round up to which decimal? Fourth decimal. After the fourth decimal, observe the fifth decimal value. Suppose it's greater than or equal to 5. You shifted 1 unit to the fourth decimal. Then we say this is round up to which decimal? 4 decimal. This is a way I have to find out constant term A naught by 2, quotient of the first cosine and quotient of the first sine. No, this is they expecting. Suppose instead of that, suppose they're going to ask in the question construct up to first harmonic. What's the first harmonic formula for construction is y equals A naught by 2, first term of the series A1 cos of pi x by 3 and then plus B1 into sine of pi x by 3. Yeah. And then I have to substitute the values. That's all. What is my 20.833 minus 8.33 into cos of pi x by 3 and then B1 is what actually minus 1.1547 into sine of pi x by 3. Suppose they're going to ask same problem construct up to first harmonic. Means I have to write this. But in this problem, the solution, this is over. I'm explaining both the situation. They're not asking to construct up to first harmonic. Now only they're going to ask constant term means a naught by 2 and then asking the first quotient of sine and cosine and sine series of the first harmonic. Now here, suppose they're going to ask for construct the Fourier series up to first harmonic means this is the way I do construct. Keep in mind before going to start the problem, first you go through carefully what they expecting the problem based on that you have to write the step. This is a way to construct uh, uh, Fourier series based on the given data is a discrete data. Now before moving to the next step, you keep in mind I'm showing entire problem in one screen, one screenshot. Now before moving to the next, first you observe what they expecting. They expecting Fourier series or affine series. Fourier series means observe whether the table is in both the case complete or incomplete. How can you know that? In the first row, first and last value must be having the same value in the second row. Then we consider as a complete, otherwise incomplete. Keep in mind why we are doing like that because function must be a periodic function, then only is possible to construct the Fourier series. Now, once you get that type of value in the discrete data, then we say that then it's possible to construct the Fourier series because the given data is in the form of periodic function values like that. Okay. Now, after that, you take overall interval, you pick the value of n, and then once you start from 0 means 0 to 2n, compare 2l is equal to upper limit, just take a first case, and then find out the value of n. Once you get the value of n, then you neglect the either first value or last value. Once after neglect, you choose the value of n. Choose the value of n after you neglect first or last value. That is 6. After that, you write carefully what is A0, A1 and B1 based on the given required and also based on the variable they involved in X and Y. Involved in first row and second row. Here they having X, first row is X, second row Y. Therefore, I have to write the formula based on instead of f of X, what we are going to take Y, instead of X is X only. Now, taking a variable depends upon what type of variable involved in the table. That's also very important. After once you write the formula, what are the values required? Must one should have to construct the table. We are going to allot the marks for construction of the table. Don't skip that construction of table. Definitely you are going to lose the marks because we are writing an answer conceptual way. And what's our next step here? And then you substitute simplify. Are you clear? And then finally we get the constant value and first quotient of first sine and cosine. The final thing is that to construct the Fourier series, now they instead of finding a constant term for first and first quotient of sine and cosine, they're going to ask same problem to construct the Fourier series expansion up to first harmonic. There is a way I have to construct. I am explaining both the things in the same problem. Thank you very much for listening my today talk. I will come and meet in the next class along with some more problem. Okay, bye, see you and take care.